Hello students, in this session we will be covering the concept of time value and return. The learning objectives of this session are to understand the concept of time preference of money and required rate of return, importance of time value of money in financing decision, concept of future value and present value factors in financial decisions and their uses, computation of future value and present value of single sums of money. The concept of time preference and required rate of return in financial decisions. Individuals prefer a given amount of money today rather than a same amount in future because of following factors. Future is uncertain. Consumption preference. Individuals prefer to consume today rather than a future. Third aspect is investment opportunities. We know that market provides innumerable investment opportunities. And if these investment opportunities are not availed in the right time, then we must miss an opportunity of earning supernormal profits. Another important concept which need to be discussed is the required rate of return. The required rate of return is simply the percentage of return which the supplier of funds wants from his investment. Now, this required rate of return basically comprises of two parts. One is the risk-free rate of return, that is the normal rate of return by investing in money market instruments, which may be generally 2 to 3%. Now, with the increase in the risk, it depends upon the nature of investment. Different investment has varying degree of risk. Now, with the increase in the risk perceptions of the investor, they want extra return, which is called the risk premium. Therefore, required rate of return comprises of risk-free rate of return as well as the risk premium. This required rate of return is used as a discount rate for present value calculations. Let us now try to understand the implications of these terms in detail. Now, the question is that why investors must consider time value of money in investment or in finance. Which one of the following two options he must prefer? Option A, rupees 1,50,000 today, or option B, rupees 1,50,000 in 5 years. Naturally, he would prefer option A as he is not getting any incentive for waiting. Now, the question is that why he wants incentive for waiting. The moment one decides to defer current cash inflows, different types of risk get involved. Thus, individual would accept future cash flows only if he is adequately compensated. This means that future cash flows must be greater than the present cash flows, which is equivalent to the risk perception of the investor. Thus, the time preference for money is an individual's or firm's preference for accepting certain amount of money today rather than the same amount in future. Money received today is more valuable than the money to be received in future. A bird in hand theory explained that a bird in hand is worth two birds in a bush. This is because of uncertainty, reinvestment opportunities, and the last is that individuals prefer current consumptions rather than in future. Future is uncertainty due to different type of risk. If we invest today a large amount when we are doing any business or investing in any projects, we are investing a large amount of fund today, but the return which we would be getting would be over the period of time, which may be in a stream of cash flow. But as the return we would be getting over a period of time, this will involve various kinds of risk such as time risk, counterparty risk, purchasing power risk, and interest rate risk. Investors need to adjust these risks by using time value of money to handle uncertainties by applying the concept of probability theory and decision tree. If current income is equal to future income, individual would prefer current consumptions rather than income in future. As there is a risk in foregoing current opportunities or current cash flows, individual wants adequate compensation, which must be amount greater than the initial value, or this must cover the risk premium that matches the risk perceptions of the individual investors. Second is the reinvestment opportunities. Market offers innumerable investment opportunities. Therefore, a rational investor or a firms would prefer current cash inflow rather than inflows in future, so that this current income could be reinvested for a better return. Now, if one decide to forego this current income, then he must get adequate compensation. Investors or firms could earn on it by reinvesting. However, if one postpones current cash inflows, he may miss this opportunity of additional return. Therefore, investor or a firm will forego current income only if he expects return more than his current opportunity cost of investment. Third is that individual prefer current consumption rather than in future. Individual prefer current consumption. However, he will sacrifice current consumption to save money for investment if adequately compensated. Due to inflation, purchasing power of future cash flow will fall. Therefore, individual would sacrifice current consumption to create a pool of investable funds only if there is probability of getting future inflows greater than the current outlay. In investment decisions, investors need to deal with cash flows at different time periods. These cash flows need to be adjusted for time value. Effective investment avenues requires comparison of cash flows, which is possible by incorporating time value. Time value helps in converting cash flows arising at different point of time in equivalent value for particular period of time, and this time value could be adjusted using the concept of future value or present value. As for example, monthly income plan. In case of a monthly income plan, the outflow is lump sum, which is at the beginning of the year, and the inflows you would be getting every month till the maturity. So, if the investor is getting more return, then only he will take this decision. Another is recurring deposits. Outflow every month till the maturity, and inflow is in one time on maturity. However, investor is exposed to certain risk which depends upon the nature of investment and risk perception. As the investor assumes more risk, he wants to be adequately compensated. Thus, expected return will increase and will be higher than the risk-free rate. Investors require compensation for assuming additional risk, which is known as the risk premium. Therefore, the required rate of return is equal to risk-free rate plus risk premium. Risk-free rate is compensation for time, which is compensation for foregoing an opportunity. Risk premium is compensation for additional risk such as credit risk, interest rate risk, currency risk, etc. Why investors estimate the required rate of return? This required rate of return is the common reference point for taking decisions. It allows conversion of cash flows occurring at different point of time into equivalent value. Now, from time preference to required rate of return, step 1 is recognize the cash flows which is greater than the cash flow later due to time preference. Second is step 2, identify the reasons, that is the risk preference for current consumption and investment opportunity. Third step is to translate the time preference into risk-free rate of return, that is compensation for deferring consumption. And fourth step is to add a risk premium for uncertainty in a cash flow, and the last is to obtain the required rate of return used for discounting and investment decision. Now, the problem one relating to the required rate of return. And investors can earn 5% on government securities taken as risk-free rate of return. C is considering a risky projects and wants an additional 4% risk premium. What is her required rate of return? If the project promises rupees 104 in 1 year for rupees 100 invested today, is it acceptable? Now, the required rate of return is risk free plus risk premium, that is total 9%. Now, the future value required after 1 year on rupees 100 would be 109, that is 100 plus 1.09. Now, let us try to understand the calculation of the future value. So, future value is equal to PV, this is the present value, money invested today, into 1 plus R raised to the power n. Now, in this case, R is the required rate of return, or K. In this case, we can take this as K is the which is required rate of return of the investors. So, 100 is the money which is being invested today, 1 plus, and the required rate of return of the investor is 0.90, and after 1 year. So, this is rupees 109, this would be 109. Now, the project offers only, we see that 104. However, the investor expectation is 109. So, she would be rejecting the project because she is getting a return less than her expectation. Now, methods for adjusting cash flow for time value could be classified into two categories. One is the compounding factor and another is discounting factor. This compounding factor is used to calculate the future value of cash flows. However, discounting factor is used to calculate the present value of future cash flows. The relationship between the future value and the present value arises because of interest rate and the time period. What is compounding? This factor is used to compute the future value of present cash flows. Key concept is that by compounding, we mean simply it is interest on interest. Now, the interest accrued in the preceding years are reinvested at the given rate, which is called the required rate of return. The accumulated amount, that is principal plus interest, at the end of the year becomes the principal amount for computing the interest for the next period. Compounding enables exponential growth in the future of an investment over time. Future value of single sum. So, future value is the value of present amount after n period at the required rate of return, say it is K, which is the interest rate. Now, the formula is for compounding is 1 plus K is the compounding factor for rupee 1 at the end of 1 year. It is used to know what will be the value of today's investment over period of time, that is on maturity. Now, this compounding factor is basically now this diagram basically explains the application of compounding factor or the future value factor. So, see, the investor is investing certain amount, say rupees 1000 today, and he wants to know what would be the value of this investment on expiry of certain period. Let us say that is the year 1, year 2, year 3, year 4 and this is the 5th year. So, in order to calculate the future value, he can use the compounding factor, which is the future value for a single sum. Single sum over here means that cash flow is taking place one, outflow is taking place at one time and the inflow would be taking one time only. So, future value, this is the value which we need to calculate, this is the FV and this is the PV, the money which we are investing today. So, this is equal to PV into 1 plus R or K raised to the power n, say n is the maturity period. So, in this case present value, investor is investing today 1000. Suppose his required rate of return is 9%, then 0.09 and the maturity period is 5. So, you calculate this 1.09 raised to the power 5. Now, this will give you the value of investment of rupees 1000 today on the expiry of the maturity period, that is the 5th year. So, the investor's wealth will grow to this amount. Now, the flow chart for computing the future value of a single cash flow. Identify the present value, annual interest I and the number of period n. So, step 1 would be compute the future value, that is compound future value 1 plus k. Second is multiply PV by CVP, that is the compounding value factor, which is FV, this is equal to PV into compound value factor. Third is that interpret the future value as an amount received after n period. Now, through this example, we will try to understand how to calculate the future value of single sum. The company want to invest rupees 2,50,000 of its surplus cash at in a fixed deposit scheme at 8% per annum, which is compounding annually for 6 years. Find the future value at the end of 6 years. Now, what are the things given? Present value is given, which is 2,50,000. Expected rate of return or the interest rate, which is 8% K, and the time period 6. Now, in this case, company is investing today this 2,50,000 and on the expiry of 6 years, 1, 2, 3, 4, 5 and 6. This is the maturity period. He wants to know the value, the manager want to know that what would be the value of wealth invested today on maturity over here. So, in order to do this, what he can do? He can use the compounding value factor. So, the company wants to calculate the future value. So, we can apply the following formula: future value is equal to PV into 1 plus k raised to the power n. PV is the current amount of investment, which is 2,50,000 and 1 plus 0.8, this is the compounding factor raised to the power 6 for 6 year period. So, 1 rupee at the end of 6 years at the rate of 8% would grow at, and its value would be 1.1 rupee 0.5869 paise. So, the value of 2,50,000 on maturity, if we multiply this compounding value of 1 rupee with the with 2,50,000. So, at the end of 6 years at the rate of 8%. Now, we will try to understand the another concept, which is the present value of single sum. Now, present value is basically the current worth of future amount, that is future value discounted at the rate k for n period. Now, present value is basically the inverse of compounding. Therefore, the formula would be 1 divided by 1 plus k raised to the power n is the present value factor. Now, present value factor declines as either k or n increases. Now, the flow chart for computing the present value of single sum, start with identifying the future value. discount rate k, and time horizon n. Now, for the given problem, future value will be identified, the investor's required rate of return need to be estimated, and the maturity period for what the amount will be invested need to be calculated. So, first step would be compute the present value, which is 1 divided by 1 plus k raised to the power n, that is the maturity period. Now, this is for if the time period is not mentioned, this means that this is for 1 year. Step 2, multiply the future value by PV. So, PV is equal to F into PV factor, and then compare PV with the current outlay to judge the attractiveness. Let us try to understand the calculation of present value of a single sum with the following example. Suppose you will receive rupees 80,000 5 years from now. If your required rate of return is 11% per year, what is the present value? Now, let us try to understand this concept first. Now, suppose you are investing for 5 years, 1, 2, 3, 1, 2, 3, 4 and 5 years, and you will be getting over here rupees 80,000. You want to know that what would be the present value of this 80,000 today, which you will be getting in future. You want to know the present value today at your required rate of return, which is 11%, okay, for 5 years. Now, in this case, we can use the discounting factor, and the calculation will be in this form. So, the discounting factor, so the present value factor for rupee 1 at the end of 5 years. So, for rupee 1, the present value would be 50 paise for 5 years at the 11% rate of interest. So, when we are multiplying this with the present value factor or discounting factor with 80,000, this will be. So, the value of rupees 80,000, which would be getting 5 years from now, hence today would be 47,440. Now, what is this use? Basically, suppose someone has asked that if you invest today 50,000 at 11% for 5 years, I will pay you rupees 80,000. Should we invest or not? So, the moment we calculate the present value, which we get that the present value of would be 47,440, and we are asked to invest 50,000. This means that at our required rate of return for 5 years, we are asked to invest more, that is 50,000 rupees. So, we should not invest. So, this is one of the practical application of present value of a single sum.